Okay, hello everyone. So today we're going to talk about information extraction in low resource languages, although it's really not just about information extraction in low resource languages. It's actually about planning how to actually deal with a task of given some new language, how quickly and how efficiently can you actually start doing NLP in it. This is really a case study in the DARPA program Lorelei, and we'll go into some detail about what that program actually was, now finished, and what the discoveries within it actually was. Um, so it's really about how to deal with a new low resource language that you want to be able to process quickly. So in some constrained amount of time, and not say, yeah, sometime next year, I'd like to be able to do it. It's like you want to do it now, and how quickly can you do it? There's also a little bit of background about how funding works for low resource languages and how DARPA in particular funds natural language processing and the consequences of the work that they've done. And we'll go into quite a lot of detail. In fact, most of the lecture is really about the Lorelei DARPA program. There are lots of languages out there with lots of good resources. So English, Spanish, German, Arabic, Mandarin really are pretty high resourced, okay? And there's maybe, another 5 more that are pretty good. There are probably another 30 more that actually have sort of reasonable resources. But we're actually interested today in the languages that have millions of speakers, maybe not tens or hundreds of millions of speakers. Round about the ranking of number of speakers in the 300 1000, where we're talking about languages that have writing systems and have media. So they have newspapers, they have TV broadcast, they have literate people who actually read and write in that language and use it for communication. They may read and write some international language as well, colonial language, but we're really talking about languages which are active, not ones which are very low resource and people who are cut off from the rest of the world. Um, Typically, if there's no immediate commercial value, so it's a poorer country, the economy is not the same as one of the big European countries or big Asian or American countries, then there's no support. Nobody's going to pay for it. Nobody's going to care about actually making that support there because nobody's going to make money out of it. And that's really how the world works. Okay. It might be that the rich people in the country already speak English, French, Russian, Putonpa, or whatever, and they already speak it. There's already support, and so that's okay. They can access their Amazon or whatever to be able to get access to resources. Now, actually, there's two things where people will develop resources, even though it's not commercial, and that's wars and religion. These are actually different, although sometimes it's hard to distinguish between them. Um, People will spend money to develop non-commercial support if they want to spread the word, some maybe capitalized for word, or if they want to stop the word, which might be the opposite. And so governments and religions will often spend time and money and resources to be able to provide support for new languages because they want to get their word out. Okay. And so therefore, we're likely to see governments funding low resource, we're likely to see religions doing it, and open source software that may or may not be a war or religion. In other words, when you're looking for resources, you'll often find the Bible, Quran is available, but you'll also find, Linux manuals, which you can pick whether that's a religion or not. I'm not going to make that decision. It's probably a religion. US government has been no different. They will fund things where they feel there is a risk, and they will fund things in non-commercial spaces if they feel there's a risk. So, DARPA and its predecessor, ARPA, Advanced Research Projects Agency, as part of the Department of Defense, really is there to fund future technology that will help both the Department of Defense and the US economy in general. And it's been pretty good at it. Okay. as things go, if you look back on it, they don't always have a very localized point in saying, we're doing this today because we know in 25 years there'll be a huge industry based on it. But actually, they've been doing things today, and 25 years later, there is a big industry that is dependent on it. So way back in the 1940s, they cared about machine translation, mainly because of the threat of the Russians, the Soviets. And so a lot of work was done in MT in those early days, really to try to understand Russian. Speech recognition in the 1970s was funded by DARPA and almost nobody else. And it grew into the 70s, 80s, and 90s. And every single speech recognition group that exists on the planet at the moment in the major companies, the people at the top were trained on DARPA programs. So that helped that revolution. Dialogue systems, and of course, ultimately Siri and Amazon Alexa. If you look at the Siri group, it came out of a DARPA program called Kalo. If you look at Amazon Alexa, the leads came out of BBN, who were funded by DARPA for years. Okay, if we look at speech translation, that was also funded by DARPA and ended up being a realistic form nowadays. Okay, so we're going to look at one particular program, fairly recently ended. It technically ended in 2019, but some things moved on to this year. It's called Lorelei. Lorelei stands for something, and I have no idea what it is. Okay, well, I could probably make something up. I think low resource something. Low resource length. Anyway, it doesn't matter. As with all good programs that you can sell to basically hire people up in DARPA and elsewhere, there's a sort of cool scenario about what Lorelei is all about. A disaster happens, earthquake, hurricane, typically a sudden one that is in some sense unexpected and something that you couldn't really have planned for. Yeah, you might know where earthquakes might happen, but it's going to be something sudden. The area affected doesn't use any of the major languages of the world. So they're not English or Spanish speaking. They speak their own native language. They have good resources in that language. So there's news, TV, radio, social media. There might be some colonial language that's around, but in general, people read and write their own language, okay? And immediately after the earthquake, there's an infinite number of news reports, there's an infinite number of TV and radio going on, Twitter, Facebook light up with in-language messages. And the question is, from the Lorelei point of view, what's going on, okay? There you are in charge of your wonderfully named international rescue, and there really is an international rescue, but those of you who are old enough to know what Thunderbirds is, that's an amusing name. How do you know what to do? Okay, you've gotten all these messages, they're in some language you do not know. Google doesn't support it. Nobody's supported it. What are you going to do? Do you like call up CMU and say, help? Well, yes, you do. Where should you provide your support? You have helicopters, you have medical personnel, you have food, you have shelter, you have medicine. Where are you going to send it? Okay. And the information is in news, radio, and social media, and somehow you have to interpret it. And desperately, you have to look around and try to find somebody who speaks this language you can translate, and you can find a taxi driver, and that's it. Now, what are you going to do? Okay. And that's the scenario that Lorelei is thinking about. Sudden outbreak of something, suddenly need to be able to interact with people. And there's going to be some interpreters, but nowhere near enough interpreters to be able to help. How can you start interpreting these streams of messages that you know have content? Okay. So what do we do? You know, we talked about this as the incident. Okay. And what we'd like to be able to do is provide machine translation in a language we didn't hear about until today. We'd like to be able to do named entity recognition. So we'd really like to know what are all the place names and people names who are involved in this. Can we identify both in the speech, broadcast news, in the newspaper articles that are appearing on websites, and the social media? Can we identify what's going on, who the actors and where the places are that are important. Also, what we did in Lorelei is we identified these, what we call situation frames. There were 11 types. Um, each of these types um, had optionally a location, a status, is it completed, is it something that's just happened, an urgency about how quickly you have to deal with it. And there was this other thing called gravity that we never really fully defined. So things like need medical attention, need infrastructure problems, bridges collapsed, houses have collapsed, we need equipment to be able to move rubble. Where's food and water required? Where is shelter required? If there is unrest, is there rioting? There's some policing that needs to go in to try to sort things out and make sure that resources are not lost. These are the things that we'd like to know. So we pre-identified what these are. We have to identify them from the information that's coming in a language we don't know. Yeah, exciting. Oh, and just to make it a little bit even more exciting, you have 24 hours to do it. So from the Lorelei point of view, you get told about the incident and the language at time 0, okay? And at the end of the program, not for the first 2 years, but for the 3 years after that, we have 24 hours to submit our first results. 24 hours, okay? So 24 hours is not enough time to go and collect data. So, but we don't know the language in advance, okay? And it's deliberately stated that you've not to cheat there and go, oh, look, we already have data for that, because we often do. If it's pre-collected, that's okay, but you can't then go out and try and find somebody to help you there. We actually had 2 deadlines. One was 24 hours, and the later one was 7 days. Because actually, in real life, it's quite likely that you're going to have a first attempt and then you could get better. In general, the 24-hour deadline was along the lines of how quickly can we use existing models, and the 7 days is how quickly can we adapt with active learning type techniques to try to get something better. Originally, for the first 2 years, we had a 30-day deadline as well, which, remembering the first couple of years we did it, the 30 days seemed to be pretty much impossible as well. But by the end, we were in control of the 24-hour one. It wasn't wonderful, but we knew what we had to do, okay? And remember, you will not know what the language is until time 0, okay? So you can't say, well, I think it's going to be this, and we could plan for it. We actually had bets on what the languages would be, just to make things interesting. And sometimes people got it. So in other words, it wasn't completely random what the language was. We weren't picking out one of 7,000. We really were picking out one of, 25. The evaluation exercises happened over, the program started in 2015. We did a bunch of things which may or may not have helped in the first year. And then in May 2016, we did a dry run, and we did Mandarin. We did Mandarin because every single team had a Mandarin speaker in it, of course. But not everybody in the team spoke Mandarin, although in the CMU team, lots of non-Chinese people can at least read it, including myself. And I'm going to tell you a little joke about that. I remember, so we have to identify locations, and we have to identify needs for those locations. And I remember one of the things that was identified in the Mandarin was the single symbol for month. And the single symbol for month in Chinese is also the word for the moon, okay? It's the same word. Arguably in English, it's got the same root as well, but in Hanzi, it's actually the same character. And we identified it as a place, we identified it as the moon, and we identified that it was a place that needed shelter, which was very amusing to all of the Chinese speakers in the group, and all the other people going, wait, what's funny about that? So of course, you have to be a little careful about your NER that's automatically doing it, because it can do stupid things, okay? Yes, that character can be used to mean the moon, but it probably isn't being used, especially if it has a number immediately before it. The first real evaluation was Uyghur. Uyghur is spoken in Western China. It's a Turkic language. It uses an Arabic script, but unlike most of the other Arabic script languages, all the vowels are actually written there. Uyghur, therefore, can be written in a phonetic form pretty easily, pretty automatically. There's some noise in it, but it can sort of be done. The following year, we were given two languages instead of one. We were given Tigrinya and Oromo, both languages spoken in southern Ethiopia and Eritrea. Tigrinya uses Giaz, which is the same writing system that is used for Amharic, and Oromo uses a Romanized form. Although Oromo was much noisier and much less standardized in the spelling. Next year we did Kinyarwanda and Sinhala. Sinhala is spoken in Sri Lanka. It's a northern Indic language, not a Dravidian language, even though it has lots of influence from Tamil lexicons, because lots of people around about there also speak Tamil. And it uses its own script. In September 2018, we actually did something a little bit more realistic. Instead of our normal, you have 24 hours, we actually worked with an exercise in Eastern Europe, which was in Albanian. And we had to provide support to non-Albanian speakers where they were running a flooding form. It was a UN exercise on dealing with a major disaster. This is a very common thing that happens throughout the year. Maybe once or twice a year, major organizations try to have a disaster test to see how well they can deal with it. And so we were brought in to be able to provide support for Albanian. And so we did. So it was a sort of live translation. They were giving us things, somebody who was in on it seeded information in various news reports and social media. And we tried to extract that information and give it to the non-Albanian speaking groups that were mainly English speaking, although they were often somewhat familiar with the area. It wasn't in Albania, it was in Macedonia. And so Albania is one of the second languages there. In 2019, we did Odia or Odia, spoken in India, and Ilocano spoken in the Philippines. Then just after that, we did another semi-live example with Tokpisin that's spoken in PNG. Tokpisin is a pidgin English, so it's got lots of English in it, but it also has lots of local language and grammar aspects that we had to deal with. The Lorelei performers, basically, these are the groups, and there was 5 groups, I think, over the whole program, but usually there was one lead and then there was a bunch of other people who worked with them. USC ISI was working with UIUC and Notre Dame. CMU was working with UW Melbourne and a private company, Leidos, that actually helped us get lots of in-domain data for disasters. BBN, which is a research company in Boston, was working with Johns Hopkins and UPenn. Within the CMU, we also had other components that were sometimes shared with other groups. So we were working closely with Columbia, not the country, the university, that were working on labeling information to do with urgency and labeling sentiment within information that's coming in. We also worked quite closely with University of Texas, El Paso, particularly Nigel Ward there, that was trying to predict these situation frames from prosody alone. So given a news report, can you identify, without knowing the language and just listening to how it's spoken, can you identify things like, is this medical? Is this infrastructure? Is this food requirement? And the answer is you can, which is like, wait, really? And the answer is yeah. So you can certainly get things like urgency, and I think you could understand that you could get things like urgency on the way somebody speaks. And we're not talking about somebody being, you know, oh my God, we're all going to die, but just the gravity of the situation when the news reader is saying things, you can often detect, independent of the language, the words in the language, how important it is, whether this thing has happened now, whether it happened yesterday, and therefore, you know, that problem is not as immediate as what it was, but you can often get this information. Um, and that's interesting, okay? And so Nigel's stuff was also integrated into our stuff, and it helped in the speech part a bit, okay? And it gave an improvement. On its own, it was, maybe only 10-15%, but it would boost things when we actually had words as well that we had to discover in languages we didn't know. CMU system was called Arial, although we almost never say that. Unlike the other teams, most of the other teams were taking whatever the target language is, often called the incident language. You'll see this on some of the slides, IL. And they were doing translation. And then they were interpreting the information from the translator in its form of English, okay? CMU was different. CMU actually tried to interpret things in the incident language itself, in the target language itself, okay? Now, it's not true that we ignored translation. We use translation a lot to help us try to decide which things to label, which things to use and not use when we were trying to boost data. So translation was used a lot, but most of the interpretation was actually done in the target language. And that seemed to be better. The results of CMU were consistently good to best compared to the other teams, okay? We mostly worked in the phonetic domain rather than in the native script. And we found it to be very advantageous to convert whatever the native script was into some sort of phonetic representation, often IPA, but sometimes romanization, or more literal romanization. And this immediately helped us start using information from other languages. So Uyghur, one of the first languages we did, that it's written in Arabic script, if you project it into a pronunciation domain, if you look across the border, you have Kazakh and Uzbek, both of which are similar Turkic languages. I can't remember which way around it is, but between Kazakh and Uzbek, one uses Cyrillic and one uses romanization, more like Turkic romanization. But once we projected all of these, we could find an awful lot of common words between them, okay? Sinhala has got its own written form, but it being Northern Indic, if we project it into pronunciation, we could start using Hindi to help us. Bengali was maybe a little bit closer. And there's lots of Tamil words that are in there. And sometimes these are the Sanskrit words and sometimes they're not. So we could also use Tamil. But because the writing system is different, you couldn't immediately do that. But if we moved into the pronunciation and learned some simple rules, we could actually do something. We had two core systems that actually tried to do this information recognition. We had a base keyword system where what we would try to do is, given a cross-lingual lexicon, which maybe we had to learn from the Bible because that's all we had, could we actually learn the translation of important words, okay? And actually, we could do a little bit more than that, because did you know that the word helicopter is almost the word helicopter in every language in the planet, apart from Chinese? But we know the Chinese for helicopter because we have that information. And therefore, international words and native words in translation, and maybe we even have access to a native speaker, which within this we did. We would have limited, measured in hours, access to a native informant, where we could actually get key translations and confirm key translations, and we would do that. The base keyword system was okay, but we could do better than that. But what made it useful is it allowed us to start selecting relevant documents where we could start doing more labeling, okay? So even though it wasn't our best system, in the first 2 hours, it was our best system. And from that, we could start feeding the other systems with information that we were getting from our keyword system to learn things. We did cross-lingual word embedding discovery, which actually is pretty interesting. I'm going to actually talk a little bit about that in the next slide. But the idea is, if you're seeded from the keyword system, can you find other keywords that have got similar co-occurrences across different sides of the language? And even though you don't have a bilingual lexicon, you can work out that these words probably mean the same, or at least, because of their co-occurrence, allow you to be able to make selections about, yep, this is about medical stuff. We did a pretty elaborate active learning because we did have access to native informants. They were not linguistically expert. We were limited to a few hours of each native informant. And the question is, how can you use those people most efficiently? Now, last lecture, Graham talked about active learning, and one of the major pieces of work that he talked about there was something that came out of Lorelei. Because we did lots of experiments, not in the 24 hours that we were actually in the evaluation, but in between the evaluations to find out the most optimal way to do this. Oh, and all of this works for speech. So we had news reports that were being broadcast, all broadcast TV, and we had to interpret the information that came out of that. And therefore we had to do speech recognition in languages we didn't know and identify named entity and be able to identify these situation frames in speech. And we could do it pretty well, okay? Which I was quite impressed with because when I first heard it, I didn't think we'd be able to do that in such a short time. A lot of this meant that you had to pre-prepare models that might have minimal adaptation within your 24 hours, because just dealing with the data, there would be lots of documents, lots of speech would be given to you at time zero. You have to process it and be able to get some cycle back and be able to update your models, and you have 24 hours to do it, okay? So there was an awful lot of pre-preparation where we were practicing how to be able to do that. We ran our own internal tests where we would run things. We typically would do both the 24-hour and the 7-day thing when we were running it, because there's sort of two types of things that you do. 24-hour has to be existing models just run, but you want to watch what's going on, because really watching for stupid things can fix an awful lot of problems, okay? And the other thing is, during the actual evaluation, we weren't allowed to sleep. Well, we were allowed to sleep, but the clever people designed their machine learning techniques to ensure that they had 3-hour breaks in them that we take to train so that they could get some sleep. Some of the techniques that we were using is, say, we would project things into pronunciation space. We would try to do morphology if we could, and if we knew that morphology would actually help. We were told the name of the language, although we could always find a way to do that even if we weren't. But we would have the Wikipedia entry, we could start reading it, we could very quickly know about the language, we could understand some history about the language, we'd know whether it's got likelihood of English or French or Spanish or Russian or Chinese. In the case of Uyghur, there's lots of Chinese words in Uyghur because many people speak Putonghua as well. So we knew about what other languages might be in there, and so we could be influenced by that when we're actually designing our system. The cross-lingual transfer of keywords is actually quite interesting. What we're really looking for is if some word appears in both languages, both texts, within the same context, okay? And a good example to think about this, imagine that you don't speak Chinese, and we're looking at the 3 characters, the 3 words that appear here. Just imagine that we've got spaces between them. And we know about that. And so we have these 3 forms, and what we discover is we know that this word means China. We know that this word means Japan. These are actually Japanese. They're not written in Chinese because we'd have a different character for China. It's the same character, but it's a simplified form. So we have Chinese, and we have Japan, and we have another one, and we wonder what that other one actually means, okay? And we know that in English, when we get 3 countries together, we often get China, Japan, and Korea. So maybe that one means Korea, even though you don't have that information. That does mean Korea, okay? And therefore you can work out, when you know about 2 words, you might be able to predict about the 3rd because of its co-occurrence. And we did this, and we didn't always say this is what the meaning of the word is, but when we're told that, when we talked about doctors and medicines, here's a bunch of other words that often appear, and maybe they mean hospital, maybe they mean ambulance, maybe they mean a particular type of medicine, maybe they mean wounds or broken bones, but we don't know. But we know that they co-occur, and we can then use that information when we're actually trying to look at other words that don't have the known words, doctor and medicine, but the other ones actually appear, and therefore we can think, yep, this is a medical one. Okay. We also cared significantly about very low resources, and so what we did was we pre-collected everything. And I think this is one of the biggest things, definitely for me in this project, was we used to know we could find resources online, but one of the things that really came out of this was we pre-collected all of the Wikipedias. We have them all aligned, which of course you have, where all of the titles are aligned. So this actually helps you getting information about named entities across language. And we also did lots of experiments about how best to use a limited native informant that's only going to be there for a few hours. Other techniques, we try to use global linguistic information about the target language, knowing something about the morphology, knowing something about the cultural use of the language and what things could actually be shared. If we knew that Uyghur was Turkish-like, we tried to use Turkish information to try to help. If we knew there was going to be borrowed words, if we knew there was British influence, we knew that petrol might appear, as it does often in Arabic as a term for gas, although maybe you think the word gas is for petrol, depending on your background. Okay, nothing is spelled properly, and nothing is consistently spelled. It's only in major languages where we have education systems which force people to have standard spelling. In all of these languages, we found spelling to be nearly random to various degrees. There's clearly not spelling checking going on. And therefore, that's a lot of noise that's actually coming into all of our models that we don't really have in the major languages. And therefore, we have to make sure that we could find good ways to be able to represent information, knowing that the same word might be written in different ways. I remember that the word Ethiopia in Oromo, which appears a lot, appeared in something like 37 different ways, okay, of different random spellings, often something to do with, where it was borrowed from when it came into the language. Did it come from English or Italian? There's lots of Italian influence, or was it coming from Amharic directly? And interesting problems I'm trying to find out how to do that. Let's look at two particular questions from Lorelei that I'd like to try to answer. So how well do humans do the task, and how well do the machines do with respect to humans? So here's a slide that we got at the end, and let me try to explain what it is. The blue one, okay, is our system, our actually 7-day system. For the first two, I think it's a 30-day system because we only had 7 days and 30 days in the first case. But all the other ones are the 7 days, not the 24-hour one. Okay, and in almost all cases, we got better in the 7-day one. The red one was the label data that was provided for testing. This was only available after the actual evaluation actually happened. So what you see is, in all cases, the humans are better at doing it than the machines, which should be the case. These are native speakers who also speak English, have been trained how to do this identification. But notice they're not twice as good. And yet they've spent, some significant time of their life to learn that language and be able to read it. And we're a bit behind. Are we useful? Yes, because this is exactly the case when you have nothing in the target language. It's a bunch of funny squiggles. You have no idea what it means. And now we can say, here are people, places, and information frames that actually come out of it. And here's a confidence level of how confident we think they are. Notice in the second one, Oromo, that actually the machines are better than the humans. And that was actually because the humans were a little bit random in their labeling, and they included things that were not clear, and between each of the 3-4 labelers, they were not consistent. In fact, the people who were doing the labeling in future years actually were much more careful about training the people and making sure that they were more consistent. And we can see that in the later form. So that isn't really the case that the machine was better. It's actually, we were still working out why to do that. And this is interesting. And, people were first worried about, oh my God, your machines are not very good. You're getting, not even 50%. that sucks. It's like, we're doing it in a language we've never seen in 7 days, which is pretty cool. So we had 25 languages that we could actually compare with. There was only about slightly less than half that were actually in the evaluation, but they provided us with other ones and we looked at that. And so we tried to see how can we predict how we're going to be in a language given the quality of the data that we're actually given, the number of things in the lexicon, number of text, the domain, the particular incident. Are we better at earthquakes than we are at civil unrest, rebellion, which some of the ones came out later? Can we actually tell? And we wanted to be able to predict that. What we discovered was that the bilingual lexicon that we start off with is pretty important. And the better and the more in domain that is, the more accurate we're likely to be. We predicted on how well we could do so the target was what was our score on the keyword model and what was the score in our neural cross-lingual model, which was usually correlated. It was better, always better than the keyword system by some amount. Okay. Here is overall 25 languages, how well we did. Some we did better than others. And we could then try to see, can we predict that F1 score based on the information that we're actually coming in. Okay. What we discovered is the bilingual lexicon is pretty important, and it's worth making that better. So finding good ways to get the native informant and the limited use of the native informant to get a better bilingual lexicon in domain is an important thing to do. We did better because we were working in the target language and not in the translation form. Though we used the translation form for often making decisions about what we were going to label and tuning aspects. And also, what the hell are we doing? Are we doing anything reasonably? And it was easier to look at the translations as well, rather than looking at us as humans and non-native for the target language. And so we did that. Also, we got better at machine translation as the program went through. At the beginning, all the neural stuff was really bad. And the statistical stuff was always better. But about halfway through this program, the neural MT stuff began to get better, partly because we had a wonderful team here, including Graham and Cindy were on that team, and we actually got much better. And we were using the neural forms better, and this was a lot of work of Graham looking at cross-lingual information and what other languages to use, and you've seen that elsewhere in this course. We also noticed that some languages are better than others, and this might be something to do with how well they're written, how standardized they're written, and what type of data we actually got. You know, sometimes the social media stuff is hard to understand. Okay, the discussion point for today is we're going to do a Lorelei scenario. Okay, I'm not going to give you 24 hours because we're going to meet later this afternoon. A major earthquake happens in Haiti. Okay, news reports, TV, radio broadcasts, and social media posts are coming in from Port-au-Prince, the capital. You have access to relief aid in terms of medical, food, shelter, and infrastructure rescue. Big machines that can move lumps of concrete. Okay, you're asked to use these messages to decide where you should send the equipment. Okay, what do you do? So you have the stream of messages and you have to do something. Okay, I want you to consider the limited resources, what you're going to do, caring about translation, caring about which related languages might you use. You'll get some access to native informants, but it's going to be limited. I'll give you 2 hours of time with them. Consider active learning, okay, and what current resources are available. So this will involve you finding out more about the languages that are spoken on Haiti and the relationship that they are to other languages, where you might be able to find native speakers and looking for other data. This scenario actually happened in 2010. There was a major earthquake in Haiti in 2010. And all of a sudden, this started happening. A bunch of messages actually came out. And the NLP community at the time said, well, what can we do? Can we do translation? Can we do anything to help? And a bunch of people got together and tried to build translation engines, tried to build human-assisted translation. So they would have people who could translate Twitter messages and give the reply, and then that was being used to be able to improve things. Today, Haitian Creole is supported by Google, and it's supported by Google because of what happened in 2010, okay? And so actually for this exercise, I don't want you to use Google Translate. I want you to pretend that that doesn't exist, okay? Because there's cheating at some level, okay? And it's quite good. It's not excellent, but it's quite good. But pretend that that doesn't exist, but look for the other parts. Okay, that's it for today.